Welcome to viewers and students. We are discussing lesson number 6, class 10 CBSE curriculum. We are discussing proportionality theorem. So let us quickly recall the proportionality theorem once again. Suppose this is triangle ABC in which DE it is parallel to BC. Now by proportionality theorem we find that AD by BD equal to AE by AC. So first you consider DE is parallel to BC. A line which is parallel to one side of a triangle divides the other two sides in the same ratio. Right. So DE is parallel to BC. So DE divides AB and AC in the same ratio. AD by BD equal to AE by EC. Then once again you recall the converse of this theorem. Suppose this time you assume that this line ADE divides AB and AC in the same ratio. If AD by BD equal to AE by EC, then DE is parallel to BC. That means this is reverse of this theorem, converse of this theorem. Here you take the DE is parallel to BC, then you find AD by BD equal to AE by EC. Then converse of this theorem is if AD by BD equal to AE by EC, then this line D is parallel to BC. Now we will use these theorems in solving a few sums here. Prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. So let us take in triangle ABC. Suppose D and E are midpoints of AB and AC. Right. So given that AD equal to BD, AE equal to EC. Now to prove that DE parallel to BC, right? Now AD equal to BD, it is given. Therefore AD by BD equal to 1, right? AD equal to BD, it is given. Again you are given AE equal to EC. So this implies that AE by EC equal to 1. So AD by BD is also 1, AE by EC also 1. You can write it as AD by BD equal to AE by EC, right? AD by BD equal to AE by EC. That means DE divides AB and AC in the same ratio. That is, DE divides AB and AC in the same ratio, right? Therefore DE is parallel to BC. DE is parallel to BC by using proportionality theorem, converse of the proportionality theorem. If a line divides any two sides of a triangle in the same ratio, it is parallel to the third side. So DE is parallel to BC. Now let us come to question number 2 here. ABCD is a trapezium in which AB parallel to DC. Diagonals intersect each other at O, so that AO by BO equal to CO by DO. So ABCD is a trapezium. Let us draw a trapezium. AB parallel to DC. So this is AB. Suppose this is DC. ABCD is a trapezium. Diagonals intersect at O. This is O, suppose, right? So given that AB parallel to DC, AO and AC and BD intersect each other at O. Now to prove, we have to prove that AO by BO equal to CO by AO by BO, right? AO by BO equal to CO by DO, right? AO by BO equal to CO by DO. You are given ABCD is a trapezium, AB parallel to DC. Now we have to prove AO by BO equal to CO by DO. Now let us draw a line from the point E so that it is parallel to AB, suppose, right? So it is an additional construction. Let EO is parallel to AB. Line EO is parallel to AB. Now since EO is parallel to AB, that means EO is parallel to DC also. Therefore EO is parallel to DC. Since AB and CD are parallel, if EO is parallel to AB, then EO is also parallel to DC. Now let us come to triangle ADB. In triangle ADB, you find that EO is parallel to AB, right? This is like EO, AB, D. EO is parallel to AB. So you apply the proportionality theorem here. That means DE by AE. You will write DE by AE equal to DO by OB, right? Or BO. You can write conversely, you can write AE by DE. You write reciprocal of this ratio, BO by DO, right? Just writing the reciprocal of this. This is by proportionality theorem. Right? If a line is parallel to one side of a triangle, it divides the other two sides in the same ratio. So AE by DE equal BO by DO. This is suppose one. Again, you come to this triangle ADC. EO, and this is A, this is D, this is C. Again, EO is parallel to CD, right? EO is parallel to CD. Since EO is parallel to AB, therefore EO is parallel to CD, because AB and CD are parallel. Therefore, AE by ED equal to AO by OC, right? This is 2. Now from 1 and 2, you can conclude that BO by DO equal to AO by OC, BO by DO equal to AO by OC, or you can write AO by OC equal to BO by DO. You can exchange BO and OC, DO. right? So this has to be proved, hence proved. Just remember this: 2 by 4 equal to, suppose, uh, say 6 by 12, suppose. You can also write 2 by 6 equal to 4 by 12, right? This is 1 by 3 and this is 1 by 3. So exchanging the middle term. So we exchange this AO and DO here. Exchange with OC and BO. AO by BO equal to OC by DO, or CO by DO. AO by BO equal to CO by DO. This was to be proved. Now let us come to question number 3 here. Diagonals of a quadrilateral ABCD intersect each other at point O, right? You are given AO by BO equals CO by DO. That means this is the reciprocal of the earlier question. You have to prove that ABCD is a trapezium. This time you are not given that ABCD is a trapezium. ABCD is a quadrilateral in which diagonals intersect in such a way that AO by BO equal to CO by DO. So you are given that AO by BO equal to CO by DO. To prove ABCD is a trapezium, AB parallel to CD. ABCD is a trapezium. That is, ABCD is a trapezium. Right? So this time you are given that AO by BO equal to CO by DO. Now let us draw a line here from E. E is a point on AD. We draw a line from E which is parallel to AB. And let us extend this line to intersect BC at F, suppose. So it is an additional construction. Let E is a point on AD so that EO parallel to AB. Right? EO is extended to meet BC at F. EO is extended to meet BC at F. Therefore, EF parallel to AB. EF is drawn parallel to AB. Now, AO by BO equal to CO by DO. This you can write AO by OC equal to BO by DO. Exchanging the middle terms here, right? This will remain the same. This is also known as alternando. In ratio and proportion, you studied this property. This is called alternando. So AO by OC equal to BO by OD. Now, in triangle, you see DAB. You find that EO is parallel to AB. EO is parallel to AB. This by construction, right? EF parallel to AB means EO is parallel to AB. EO is parallel to AB. So if AO is parallel to AB, by proportionality theorem, you can write DE by AE equal to DO by BO, right? By proportionality theorem. This you can write AE by DE. This you can write AE by DE equal to BO by DO. So this you treat as 1. AE by DE equal to BO by DO. Again you come to this triangle. You see BO by DO equal to AO by OB, right? Or AO by OC. BO by DO equal to AO by OC. Therefore, AE by DE equal to AO by OC. Why? Since AO by OC equal to BO by DO. This was we proved earlier, right? So you find that in triangle ADC, AE by ED equal to AO by OC. That means EO divides the other two sides in the same ratio. So EO is parallel to CD. Therefore, EO divides AD and AC proportionally. Therefore, EO is parallel to CD. Now earlier EO is parallel to CD means EF, that is EF parallel to DC. Now earlier EF was parallel to AB. Therefore, EF parallel to AB and EF parallel to DC, which implies that we conclude that AB parallel to CD or DC. That means two lines parallel to the same line are parallel to each other. This we discussed in Euclid's axiom earlier. Two lines parallel to the same line are parallel to each other. We find that this line EF, it is parallel to AB. EF is also parallel to DC. This line is parallel to AB by construction, right? And now we prove that EF is parallel to DC here. So two lines parallel to the same line, they are parallel to each other. AB parallel to CD. Therefore, ABCD is a trapezium. Right? So thank you, viewers. With this sum, we concluded the exercise 6.1. This is exercise 6.2 of class 2 Ncert curriculum. Next, in the next video, we will discuss the criteria by which we can say two triangles are similar. Right? Similarity criterion we will discuss in the next video. So keep in touch.